Why did your friend get his card after his birthday? Postulate. Postulate, post, mail, late, postulate. Anyways, so let's go ahead and take a look at some triangle congruence theorems, which do involve some postulates, or I should say, postulates. This is an applet that I created using GeoGebra, which you can download for free, by the way. And what I've done is I've created some sliders that you can use to adjust the lengths you want to try for your triangle. The nice thing is you can actually see the inequality, triangle inequality theorem, because if I make one side too long, I won't be able to make the other two sides connect. So how can I go ahead and actually see how I can make this triangle? So let me go ahead and just set it to a number, and we'll set this one to 8. Why not? And you can adjust these points to make the triangle connect. Now, one thing I did on purpose is I went ahead and showed the circles that you can make with these segments. So this segment 7 can make this circle. All these points on this circle are equidistant from point B. So I can tell just by looking at the other circle that I probably want to set that point there. Same thing for this segment, the 8. Now, when I finally make them touch, you can see the triangle I make. It has side lengths of 7, 8, and 10, and angles of 43, 82, and 55. Okay, all right. Well, I see there's actually another point I can connect. Maybe this will be a different triangle. And I guess I didn't get that quite right. You have to get them really close together. There we go. Okay. Oh, it's the same angles, 43, 82, and 55. So no matter how I set the lengths, assuming they're a valid triangle, there's only one combination that I can make. So this triangle with sides of 8, 7, and 10 is also congruent to the bottom triangle with sides of 7, 8, and 10, which leads us to the theorem that side, 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 if two triangles share the same sides, then they will be congruent. This bottom one's a little more finicky than the top one. I think I have to go higher. There we go. There we go. So if two triangles have matching sides, then they are congruent. So the side, side, side postulate says, if you know all three sides match, and I don't mean all three sides within the triangle, but if you have three pairs of congruent sides, then you can say that the triangles are congruent. So every side of one triangle is congruent to the corresponding side of the other triangle. Now we're looking at side angle side combination. So I have the slider so I can set the length of AB. AB here is 7. AC is 5. And the angle I have it set at 63. I can keep moving it until it's an angle I want to play with. So I'll just leave it at 63. Because I have this side is constrained, it has to be 5. This angle is constrained, it's now 63, and this side is 7. The only free side I have is this one. But if I want to make it a triangle, I have to connect it to C. And there's only one way to connect it to C. So you can see I still have the 63 degrees. This will be 74 degrees, and that'll be 43 degrees. Now, let's say I try to mix it up, and I'm going to make AC 7 and AB 5. All right. So kind of the same combination, but the sides are flipped. And if I move it, you'll see that I still have the same combination of angles. I still have the 43 degrees, the 74 degrees, and the 63 degrees. So even if you rearrange these two sides, as long as that angle is between them, then it's fine. So this is called the included angle. Let me go ahead and move this side. This angle right here is the included angle because it's between the two given known congruence, pair of sides that are congruent to the other triangle. So if I have any two triangles with sides of 7, angle of 63, and a side of 5, they are automatically congruent by side, angle, side. And they will have that. Now you see that if we have a side, an angle, and a side congruent among two triangles, then we can also say the two triangles are congruent. This is called the side angle side congruence postulate. Note the congruent sides must both be connected to the angle. The angle has to be the included angle between the two sides. In this one, we're looking at an angle-side angle combination. So this angle 1, you can see I can adjust this angle right here. And I can adjust angle 2. There we go. To anything I want. So looking at this, I have the angles are anywhere I want them to be. Now this side, I can only move it along this angle. All right, so I can't get off the angle, otherwise it's not making that angle. If I try to move this point over here, then it's not 80 degrees anymore. So that's why this point has to move along this dashed line. This 9 is determined by here, so I can set that value to any value I want. So I'll leave it at 8 now. And then finally, I have this angle, which is 57 degrees, and I can move this point anywhere along that line, but I can't rotate it, otherwise it's not 57 degrees anymore. So you can kind of see that there's really only one place I can put the 2 points to make my triangle, which is right there. So there's only one way to put together this triangle, which means that if I have an 80 degree, 8 length, 57 degree triangle, if I have 2 of them, they will automatically be the same size. One other thing I wanted to mention is that it's very important to know which side is the included side. So here you can see this side with length 8. It is the side of this angle, 80 degrees, and the side of the 57 degrees. So if the angle had been up here and skipped a side, then that wouldn't have worked. So it has to be angle touching side touching angle. In the angle side angle, you know if you have the angle and included sides, so the angles include this side right here, then so if you have pairs of congruent angles and sides, then you can say the 2 triangles are congruent. Now we're going to look at a combination of angle, angle, side, and determine if there is only one way to make a triangle with a given combination. So here you can see I have one angle set for 74 degrees, one angle set for 63 degrees, and then I set my length here, whatever I want it to be. So I have this so it can move freely because it's just supposed to be 74 degrees. But it needs to be connected to this angle down here on the bottom. So the 63 and the 74 degree angles are connected, but I didn't say how long this side has to be. Now I do say how long the next side has to be, which is on the second angle, and I've set it to 10 here. How many different ways can I make a triangle by keeping these 2 angles the same and then the length that I specified? Well, you can see there's only one point it can pass through when it makes a 42 degree angle here, which kind of makes sense. 74 plus 63 is 137. Let's see. Oh, I must have a rounding error. That should be closer to 43. But it should add up to 180 degrees. So it won't match up until it won't meet until all the angles match up to make 180 degrees. So I can slide this around as much as I want, but the main point is that there's only one way to make this triangle. If I make this even tighter, you see I can slide this around until I make it. And there we go. That one works out well. No rounding error. So you have 46 and 63, that's 109, plus 71 is 180 degrees. So there's only one way to make that triangle, 46, 63, and a side length of 10. So having angle, angle, side is good enough to prove something congruent. Angle, angle, side also works as a theorem to prove that two triangles are congruent. So you could have an angle, an unconnected angle. You don't have to know this side. If you actually know this side, that's good enough to prove that the triangles are congruent. If the corresponding angles are congruent, and the corresponding side is congruent.